In this video, we're going to go over authorization flaws as it relates to application security. So let's start with a little game. I want you to get from the start of this maze to the end of this maze before I do. On your mark, get set, go. Did you beat me? Maybe you did, but probably you didn't. The reason why is probably some of you took the path that, as you can see here in green, and it would have taken you a whole lot longer to get to that final destination. Some of you may have even found a better approach and taken this yellow path to avoid half of the green path. Did any of you consider just bypassing the entire maze to get from the start to the end? That's all I asked you to do, is get from the start to the end. I didn't say how. Now, this is an example of a direct object reference. If a user knows a specific value, they can get to that particular destination. So take, for instance, if we don't protect a web page, but someone knows the URL of that web page, all they have to do is type in that URL, and then they have full access to that web page unless we have the protections in place to guarantee a user can't see that. So let's look at an example of this. So log into orman.creighton.edu, navigate to the course directory, look for authorization flaws section, and then open direct object references. Read the description on that page, and then what your goal is to exploit the get URL. So get is basically you have a parameter in the URL itself with the equals after it. What you need to do is put in a value that would exploit this parameter to be able to reveal users' information. Pause this video, come back when you have attempted this exercise so that we can compare your answer. Okay, welcome back. So here we are at the direct object references page. This is an example I built that follows something that happened in the real world with a company called LifeLock. So with LifeLock, they had an unsubscription page where any user could just type in a value and be able to figure out information and unsubscribe any user from LifeLock. LifeLock is trying to protect personal information from being exposed, and they had a breach with this specific instance. So for example, what we're going to do is go up here. We can see inside the URL. This is the typical URL that you're going to see. The question mark, however, is going to indicate a value. So we're going to look for a subscriber key of a value that we're going to put here with the equal sign. So I'm going to just go ahead and type in 1. And when I do that, you can see the selected user does not exist. So we could just keep tinkering around with this and see if we could find a user, maybe 80. Nope. So let's try 101. We eventually land on that 101 works. And we can see that it says use the fields below to unsubscribe Declan Parker from email communication. So they could check this and then unsubscribe. If they were to then change the subscriber key to another number, we have another name. So the problem with this is that LifeLock allowed any user to type in any number into the subscriber key, and they were able to see the information of users. And then someone could build a spear phishing message targeted directly at this individual, knowing that they used LifeLock services. All right, the next type of attack we're going to talk about is the directory traversal attack. So first of all, we're going to have a root directory, and inside of that root directory, we'll have a www root directory, which is going to have access to all the web application files. If you wanted to access, for example, the quarterly report, you could then dive into a folder by adding /reports at the end of that, and then /quarter.html, and it would open up that quarterly report. At the end of the URL, you could also access money.docs by adding public/docs/money.docx to be able to pull in that file. Stepping outside of the www root directory, we can then go into other directories that would give us access to restricted files, such as the etc directory, which could have access to the hashed passwords. So how could someone exploit a system where they have access to these files, but then be able to step outside of here to be able to gain access to these restricted files? Well, they're going to use the change directory command that we taught you in command prompt or terminal, where if you hit ... you can go back a directory. So if I wanted to go from this quarter.html page, I could go back a directory by saying ... Then now I would be in the www root directory because I have stepped out of the reports directory. Let's say I wanted to then step into the root directory, so I do ... one more time, so I'd have ... that would give me the root directory. Then I could do /etc/password, and that would give me access to these files. So let's have you guys try to exploit this vulnerability. Again, go to orman.creighton.edu. This time we are going to go to the specific page that I have linked here. See if you have access to this page, and then navigate to the course directory, look at authorization flaws, open the directory traversal attack, read the following in the page description, and then try to submit the form to allow you to view the file contents that you tried to access in step 2. Go ahead and pause this video, attempt this on your own, and then come back here to compare your answer. Okay, so here we are at the directory traversal attack page. What I'm going to do is just paste in the URL that is in the slide and see what it returns. As you can see, it returns a 404 error indicating that that page does not exist, or so we think. So with this directory traversal attack, what we want to do is manipulate some of these to be able to gain access to this folder that I'm specifically telling you. So as you can see up here, we are currently in the security folder, learning activities, authorization flaws, specifically the directory traversal.php file. So what's common between these two URLs is this security folder. So I need to gain access to supporting files. So what I'm going to have to do is get back to the security folder and then step back in. So in order to go back, I need to go back 1 directory, 2 directories, and then what I need to do to get to the security bypass folder is I need to then step into supporting files and then step into security bypass. So as you can see down here, we have a menu where I can go ahead and pick a file, and it will actually preview this just like what we did on our previous exercise with LifeLock. This is going to say you were unsuccessful at previewing a file you're unauthorized to view, because what we want to do is manipulate this to give us access to something that we shouldn't be able to view. So in order to do this, I'm going to inspect in order to see the source code. Each browser is going to be different. What I'm going to do is look into here and see where it's opening. So we can see that this list item, which refers to this directory object references, has a folder that is going to tell me exactly where I should go. So it wants me to go into the security/learning activities authorization to be able to preview this file. Instead, what I'm going to do is just step into the security and then supporting files, because that's what I'm looking for. And then we're going to add security bypass at the end of it. If I select this item, it will now go into security, supporting -file, security bypass. Let's go ahead and select this file, click select, and it is going to show me that I successfully performed a directory traversal attack. This is that page that we tried to open previously, but as you can see that it does open because I performed this attack successfully. Now, there is another way of doing this, so using the ... that I explained to you. So what we're going to do here is look at our URL up here, and we're going to step out of authorization flaws and then step out of learning activities to be able to get into the security folder. So what I'm going to do is come back to this ID, and I'm going to set it equal to ... so that's going to get me out of the authorization flaws, ... that will then get me into the security folder. And then I'm going to dive into supporting files /security bypass. And then I click out so that it saves that. I go ahead and click this, make sure that I have the one that I changed clicked over here, click select, and you can see that this as well did perform a directory traversal attack. So just because we have something outside of a folder and no one has direct access to it doesn't mean they can't manipulate our application to be able to gain access to certain files. So we need to make sure that we protect the root directory, because we don't want someone to gain access to unauthorized information. Another authorization attack that is less common but still exists is code quality. Sometimes developers leave comments inside of their code kind of telling them, hey, I need to address this or fix this later. But a lot of times what happens is they end up leaving this code in their application for anyone to see. So for example, an HTML comment looks like this. We have less than, !, and then the comment, and then .. greater than. JavaScript and PHP have a single line comment using // SQL has a single line comment using -- space or even £. And then we have a multi-line comment in JavaScript, PHP, and SQL that is /*, and then we end our multi-line comment with */. So something that would look really bad is if we said something like, code needs fixing right here, it bypasses authentication. Well, if someone sees that code, they could exploit that code to be able to gain access to a system, for instance. So what I want you to do is log into orman.creighton.edu, navigate to the course directory again, look under the authorization flaws, and then open Relying on Obscurity. and then read and follow the page description, and then find and exploit the hidden login credentials. So pause this video, try this on your own, and then come back to compare your answer. Okay, so here we are on the Relying on Obscurity webpage. So what we want to do is exploit this code to be able to gain access to the system. Make sure you don't enter in your actual credentials because everything that you type in here will be recorded. So what I'm going to do is do the same thing that I did with the directory traversal. I'm going to inspect the page. But this time, what I'm going to do is just scan the page for anything that might be of interest. See if there's anything code quality related. And just by clicking this icon up here and then hovering over, I'm able to see some code. And so we see some green. This looks like a comment. This says, remove this code before putting it into production. This person must have forgotten to take out this comment. Oh, look, it has the admin password and username. So I'm going to give admin, and then this is a secure password. Hit enter. And then it says that I have successfully identified the code embedded in the web page. Now, this could have a lot of repercussions if someone is able to gain full access to a system just because someone left a comment with the credentials available to anyone to see.